Good morning. So in this video, I'm going to discuss ideal work. So ideal work is the reversible work that you can obtain from the process. So we're going to derive another equation to calculate ideal work. And then we're going to use this equation to solve a problem. So ang application ng ideal work is also to determine whether a process is possible or impossible. Just like entropy generation calculation. So let me share the PowerPoint. So we're going to start with the equation for calculating S generated. So when you're going to consider the equation for S generated at the steady state and reversible process, we have this equation. We have this equation. Delta S minus heat divided by T surrounding is equals to 0. This happens when the process is reversible. So if you're going to isolate Q dot from this equation, um, basically by transposing the second term to the right, and then transposing T surrounding or T sigma to the right, to the left, we have Q dot is equals to T surrounding times delta S, or delta S M dot Fs. No? And then let's recall the general energy balance equation wherein we're going to consider the W as reversible. So when the work is reversible, we can replace Q, no, right here with T sigma delta S M dot Fs. Remember, Fs is flow stream, no? So this is our current equation. So Ws reversible here is also defined as the W ideal, W dot ideal. So just isolate Ws reversible and change its name to W ideal dot. So that would be equal to delta H plus 1/2 B squared plus Cg times M dot Fs minus T sigma times delta S M dot Fs. Okay. So when we neglect the potential energy and the kinetic energy on this part of the equation, we're going to have delta S, W ideal is equals to delta H M dot Fs minus T sigma times delta S M dot Fs. Now, if we're going to consider a system wherein we have one entrance and one exit, no? Yung f of s natin, ang kamukha nun dati, mawawala siya. Tapos yung m dot, constant na siya. So if we multiply both sides of the equation with 1 over m dot, okay, right here, we're going to multiply this part of the equation with 1 over m dot. W dot ideal divided by m dot is equal to W ideal. And then we're going to cancel out this m dot on the right side of the equation. And we have this delta H minus T surrounding times delta S. So equation 5.27 is the equation that we're going to use to calculate W ideal. Okay? And then if it so happened that you are unable to remember the equation for W ideal, you can open up the handbook, and then on the 8th edition, you can look up at page 4-39. This is chapter 4. Chapter 4 is thermodynamics, page 39, and then you will have the equation for W ideal. So another way to remember this is to, if you still remember the equation of delta G, no? So the equation of delta G is delta G is equal to delta H minus T delta S. So it's quite similar to the equation of delta G. Yun nga lang, the temperature is T surrounding. And then, syempre, this delta G will become W ideal. So, ito sa physical chemistry, ang tawag natin dito is the Gattas equation. Ano? So, Gattas. Ganun din yung equation ng W ideal. Okay? So, let's try to solve example 5.7. Okay? So, example 5.7. What is the maximum work, that's the W ideal, that can be obtained in a steady state flow process from 1 mole of nitrogen? Assume an ideal gas. So ang gagawin natin, we're going to use, since nitrogen is a diatomic molecule, we're going to use Cp is equals to 7.5 R. No? So hindi mo na natin gagamitin yung nasa table. Kasi sa board exam naman, pag ganito yung problem, walang binigay na Cp dependent, Cp temperature dependent, ang default nun, gagamitin nyo yung 7.5 R. So gagamitin natin yung 7.5 R na Cp. Ano? So, the initial condition is 800 Kelvin and 50 bar. So, take the temperature and pressure of the surrounding as 300 Kelvin and 1.0133 bar. So, basically, pag nagka-calculate tayo ng ideal work, i-assume natin na yung final state ay yung temperature at saka pressure ng surrounding. So ito yun, ito yung final state. Ano? So basically to solve this problem, we're going to use the W ideal equation. Ano? The W ideal is equals to delta H, Gattas, no? Minus T surrounding. T surrounding is, or T sigma is 300 Kelvin. Tapos times delta S. So pwedeng delta S muna yung i-solve natin. Tapos ito namang Cp delta, itong delta H, pag ideal gas kasi, Cp delta T lang to. So ito yung final temp, ito yung initial temp. Madali lang naman yung namin. Pwedeng sabay diretso na tayo. Step number 2, makakalculate na natin yung W ideal. So calculate na natin yung delta S. So in order to calculate delta S, kasi may variation tayo sa temperature at saka pressure. So gagamitin natin yung equation na R ln P1 over P2 plus Cp ln P1 over T2, T final divided by P1. So I hope tandaan nyo pa itong equation na to from physical chemistry. So just substitute everything. So halimbawa gumamit tayo ng R na 8.314. Joules per mole per Kelvin. Tapos 1 mole of 1 mole of nitrogen. So mawawala lang to pag ginigit natin ng 1 mole. Tapos Ln. So the initial pressure is 50 bar. Magka-cancel out lang naman yung unit niyan. So you don't really need to convert the bars. Divided by 1.0133. Tapos plus. So Cp is 7.5. Tapos times 8.314. Tapos times Ln. The final temperature is 300 Kelvin. Divided by 800 Kelvin. Okay? So, using your calculator, you can calculate delta S. You should get something like 3.87. So this is 3.87. And then the unit is joules per Kelvin. Tapos right now, we're ready to calculate W ideal. So W ideal is, yun muna, Cp delta T. So 7.5. Tapos times 8.314. Tapos the final temperature is 300 Kelvin. minus 800 Kelvin. Okay? Tapos, minus. So, minus to ano? Sa gatas, minus yan. So, T surrounding is 300 Kelvin. Tapos, yun, 3.87 times 3.87. So, ito ang unit nito, joules per Kelvin. Tapos, minultiply nyo ng Kelvin. So, ang magiging final answer nyo dito is in terms of joules. Okay? So, joules yung magiging final answer sa WID. So, pag pinindot ito sa calculator, you should get something like negative 15.71 kilo. Yes, it's negative 15.71 kilojoules. Ano? So, pag dinivide nyo ng 1,000, you need to divide this by 1,000. You will get the negative 15.71 kilojoules. Yung final answer. Okay, so it's relatively simple. Ano nga application ng WIDL? Probably, karamihan naman kasi ng mga machine, they are made to produce work. Yun naman talaga yung topic ng thermodynamics, yung objective ng thermodynamics. So, yung WIDL, yun yung maximum work na mapuproduce ng machine. No? So, pag yung negative value dyan, ano lang naman yan, convention, kasi medyo baliktad lang yung convention natin sa chemical engineering. Ano? So, ibig sabihin yan, it will produce 15.71 kilojoules of work. No? So, pag halimbawa, may inventor, tapos kinlaim niya yung machine niya, halimbawa, ito yung process niya, and then, ang kiniklaim niya, halimbawa, you should be able to produce 20 kilojoules. So, hindi nyo ika-grant ng patent yun. Ano? Kasi hindi siya nagpapalo ng second. Pero pag less than this, pasado siya ng pasado siya ng second law of thermodynamics. Ganun yung application niya. Ano? So, if you're going to check the solution kay Banes, medyo may konting diferensya. Ano? This is 15.973. Ano? So, ang kaibahan dito kasi tayo 15.71. Siya kasi ginamit niya yung yung value ng CP, yung CP sa chapter 4, no, sa heat effects ko natatandaan niyo pa. So, sa board exam kasi hindi naman available yun, no. So, pag may ganitong problem, ang ginagamit lang natin yung 7.5 R na CP. Okay, so actually medyo malapit naman, no, 15.71 at saka 15.97. So, hanggang dito na lang muna tong video na to. So, see you on the next video.